would write 10 plus or minus 2 square root of 5 over 2, and the 2 goes in each of these. It's like you would write it 2 times 5 plus or minus square root of 5 over 2, because you just pull 2 out as a common factor, and then these cancel.
So it would just be 5 plus 5
Yes.
squared. So it's confusing as when some of these want you to like leave it as this or something.
Yeah.
You know. And
So
they're, like,
after you
answer.
simplify the numerator as far as you can, then you look to see if you have a common factor. So even at this stage, you don't have to pull out that. You just say 2 goes into 10 5 times, and 2 goes into 2 1 time. But you're not used to doing that with pluses, with addition in the numerator. You're used to doing it with multiplication. So that's why this step helps. If you pull out the 2 here, then you know, since this and this are multiplied, you can cancel common factors. It's my daughter telling me. So you start out with 840, right? And that's going to be equal to 4 times 210.
So it's
So you
just
have
140
210 up
squared?
here, and that's
How I
going to
write
be
it?
equal
Or
to
I
21
had to put
times
x
10.
plus 140
X
squared?
plus 140 parentheses squared.
So you just tack a 0 on the end to get it to be 210. And that's 3 times 7, and that's 2 times 5.
Just x squared
So none of these are the
it
same.
plus?
So you have no perfect squares
plus x squared?
that you can take out of this. So that means
And
you
then
leave the
equals
210
340?
inside. So if you had come out with 3
That's
times
fine.
7 times
340
3
squared.
times 5, for instance,
Yes.
then your factors would be
Are you burned out on listening to all of us?
that, and this is a
Have some
perfect
chocolate.
square. And you could pull it out of your radical, leaving 7
Would you
times
do
5.
add it to the 4 or something?
You would pull out a
Did I set
2
it up right?
for the 4 times a 3 for the 3 squared.
Okay.
So, in other words, if you had 4 is 2 squared times 3 squared times 35, if this is what you
But
had,
aren't I going to just get right back to this?
then you can pull out the 2 and the 3, which gives
Oh, okay,
you
so I'm gonna
2
get it
times 3 on the outside.
2x
So that would be 6.
squared, right? Just 2x. Just x squared.
But that's not what you have. You have,
Yeah, I see what you're saying. Yeah, that's
you
what I
have
was
this,
curious about.
X squared.
yeah,
If you could pull
Okay.
more out, so you would
And then that's
multiply them.
first outer.
right.
Okay. Plus 140x.
So you have 16p squared minus q squared over pq
I should be passing
over
because I was passing
4
before.
over q
I took.
minus 1 over
I'm
p.
not passing right now because I'm taking.
And
6.
so your first step is to simplify as much
Yeah.
as possible. And I think you did this correctly. You have a
Okay.
difference of squares here. So when you have a squared minus,
Just pull out a square, or would that not do anything?
it's going to factor to this. If you have a squared minus b squared equals a plus b times a minus b. So 16 is 4 squared. 4 squared. So you have 4 squared times p squared, which is a would be 4p and b would be q. So you have 4p plus q
Minus 4p minus, or
times you over pq, and then over your denominator. I know, isn't that awesome? Okay, so once you've simplified as much as you can, then you use the rule for dividing fractions, which is keep the numerator. Well, you have to rewrite it horizontally. So you write 4p plus q times 4p minus q over pq divided by, and then what's in the denominator? 4 over q minus 1 over p. Okay, so you're just writing it horizontally. So let's look at the denominator for a moment. You need a common denominator, so what would the common denominator be?
Wait. Sorry.
If you're,
No, I'm looking at this part. Where'd this come from again?
this is this.
And you just pulled the P and Q out?
The numerator is this. Numerator of the complex fraction is just this. And then the denominator is that. And this line in between means you divide it.
Right.
So I just wrote it out as this fraction here divided by this here. So you,
Oh, okay.
so if you had 4/3, that's equal to 4 divided by 3.
Oh, you want some chocolate?
That's really all I did. This is the 4 and this is the 3. Okay, so let's look at this. 4 over q minus 1 over p. And you need a common denominator, so what would your common denominator be?
PQ.
Yeah, PQ. So you multiply everything by PQ. Well, you want everything on the denominator to be PQ.
Right.
So to make the first one PQ, you have to multiply the numerator by P. To make the second one, you multiply the numerator by Q, right? Because Q over Q is 1, so you're multiplying this by P over P and this by Q over Q.
So the denominators cancel out, or?
Well, they're the same now, so that means you can add the numerator. Okay? So once you do that, that's going to get very small up there. Then you go back to writing that, and you have your first numerator was
See you later.
4p plus q times 4p
No, thank you.
minus q over pq, and that's divided by this 4p minus q over pq. So are you lost?
A bit.
Yeah. So we took that denominator we started with in the original problem.
Wait, why'd you do this? We already had it down
Yeah, here I was just working
here.
on the denominator. So here I just pulled this denominator here to simplify it, so that I had something over something else. So before I had this here, now I've rewritten that to be this. This and this are the same thing. And that's all I'm doing. I'm just rewriting this
Okay.
here. I'm sorry it's so messy.
That's fine.
Okay, so when you have a division of two fractions, use the Kfc rule, which means keep the first fraction, flip the second fraction, and change the division to multiplication. So if you had, again, our 4/3 divided by 3/5, you would keep the first, you would flip the second, and then you would multiply instead of divide. So that's a basic fraction rule. And so applying it to this, you keep the first, which is all of this. And you flip the second, which is PQ over 4P minus Q, and that is now multiplication. So So now you can reduce it by canceling things. So what can you cancel? Right. So you're left with this. So that's equal to 4p plus q. So that's that answer?
Jeez, I don't know if we're doing all this work.
Yeah. Well, that was a quick lesson in complex fractions. I mean, I think we pretty much covered everything just talking about this. But in this one, you either know it or you don't. Do you know it?
I don't remember it, honestly.
Okay. The domain is just all the values of z that will work, possibly. It's not the solution, but it means it's legitimate. And the only illegitimate thing is if your denominator is 0. You can never have a denominator be 0.
So the answer can never be 0.
The answer, z cannot be 4, because if you had z equal to 4, then your denominator would be 0, right? Plug 4 into there.
That way she's gonna have 10.
Yeah.
Okay, so the way you check that is you take your denominator, z minus 4, and you set it equal to 0. So z equals 4 makes the denominator 0. So z cannot equal 4. So the answer is all real numbers except 4. So the number that should be excluded is 4. Okay, so the correct answer is z such that z does not equal 4. I'm going to say it again. You can ignore the numerator when you're trying to find numbers that are not in the domain. It's all about the denominator. So you don't want your denominator to be 0.
So like denominator, numerator, denominator?
Yes.
Oh. Let's try that again. Wow, right, so this is W.
So you're trying to find the values of w that make it 0. So you have w minus 4w plus 1. So the zero factor property is something you need to know, and that says that if you have a times b equals 0, then that means either a equals 0 or b equals 0. So in this case, it means w minus 4 equals 0, right? Because this is times this, or w plus 1 equals 0. So if w minus 4 equals 0, it would be 0 times anything would give you 0. Or if w minus 4 is something else, but w plus 1 is 0, 0 times that something else would still give you 0, because 0 times anything is 0. So how would you solve for w here, right? So w is 4, or w is, right.
That's right, because it's the one you, yeah.
So anytime w is 4 or w is minus 1, you're going to get,
Oh, I remember doing this to fact. This is all just factoring stuff out.
it will be. Right now, it's just watching out for your denominator. So if w is 4 or w is negative 1, you're going to get a 0 in your denominator. But you're not allowed to do that. That's illegal. The math police come after you. So, so those have to be excluded from your solution.
So when you put this on here, so should we exclude it, or I guess
The other one, you use the U because you got the guy.
when you do this, you go.
Yeah.
I'm sorry? No, there isn't. But
You just set them like that, or do you have to do two different?
I don't know.
no, you
Okay.
can't use those computers. Okay, thank You're welcome.
Multiplied. In other words, first make everything into things that are multiplied.
Be that Z over 4Z.
On the denominator, yeah, okay, you did it right. Okay, so then you're multiplying them. So how do you multiply fractions?
That's a good question. One of which
First you reduce, which you did. So these canceled, and you had z over 4z plus 1, which is what you have. So then after you've reduced as much as you can, and you can't reduce this way or this way either. Well, actually, that 3 you talked about, let's pull it out. You have z over 4z. Yeah. So you have 9 times 4z plus 1 over 8. Okay, so now you see that you can cancel something else out.
cancel that out.
Right, you can cancel these out.
So the answer's 9Z over 8.
Right.
Nice.
Yes, so it's good that you saw that there was a common factor up here. This problem, you were talking about taking the this denominator and switching it around. So you do that by multiplying by -1. So this becomes -2 over, and -1, you distribute it. -1 times 1 is -1. -1 times -y is positive y. And so that becomes 2 over y minus 1. -2 over y minus 1. So when you see a 1 minus y, you don't even have to do all of this stuff. You can just...
Switch them and make it a -2.
Right, right. Okay, so now you have y plus 1, y minus 1 over 8y times -2 over y minus 1.
Knock those two out.
Right, you can knock these two out. Is there anything else?
It's not.
There is this.
You divide. That's what I'm saying. Can you divide these two?
Yes, that you can reduce by a factor of 2. So there it goes. So 2 goes into 8 4 times. 2 goes into 2 1 time. So, and then that's all you can reduce. So then what do you have left? You have y plus 1 over 4y times -1 over 1, because we cancel the y minus 1s out.
So it'd be negative parentheses y plus 1
Right,
over 4y.
yeah. And that's your answer.